Okay, so today we're just going to look at this simple winch and motor drive dynamics and machines question. The question says, the diagram below shows a simple winch. The motor drives a small gear and the large gear rotates the drum and raises the load. You can see the load here being raised by this winch. The load is 37.5 kilonewtons and is raised at 0.825 meters per second. The system is 40% efficient. So 5 things we've got to find. First thing they want, torque. Calculate the torque acting on the drum. Second thing we need to find, power produced by the load. The speed of the drum, and it specifies in revs per minute. Quite important that, because any answer we get will be in radians per second, so we need to convert that to RPM. When it says the speed of the drum, this is the drum here, this is the winch motor. Okay, fourth part, power produced by the motor, and finally the speed of the motor in RPM. Again, we need to make sure we convert our units at the end to get the answer in RPM. Okay, so initially we're told the motor drives a small gear and the large gear rotates the drum and raises the load. In this case, the load is 37.5 kilonewtons and it is raised at 0.825 meters per second. We have a linear speed there, and the system is 40% efficient, or 0.4. Okay, so we can see here the diameter of the drum. We're also given the number of teeth on the reduction gear, 125 on the drum and 25 on the motor. So that will help us in the end work out the speed of the motor. Okay, so let's have a go. So part A, torque on the drum. We know torque is equal to force times radius. This force must be in newtons, and this force here must be, this radius, sorry, must be in meters. Okay, so what's the force? Well, we know the load is 37.5 kilonewtons. The radius of the drum will be simply that diameter divided by 2. So that'll give us 37.5. Remember, this is kilonewtons, so we need it times 10 to the 3. Times by a radius is 215 millimeters. 215 times 10 to the minus 3 meters over 2. So that gives us an answer of 4031.25 Newton meters. Whoops. So that's the first part there. Okay. Part B. It asks for the power produced by the load. Now, we have a few formulas for power. We know power is force times velocity. Power is work done over time. And power is also equal to omega T. Now, we know T and we can find omega, so this is the formula we're going to use. So, omega. Remember omega, that is always in radians per second. However, we've been given a linear velocity, so we need to convert that. Now, we know from the formula V equals omega R. We know R, we know V, we can find omega. So omega is equal to V, 0.825 over 107.5 times 10 to the minus 3. And that gives us an answer of 7.67 radians per second. Okay, so we've already found T. So it's literally a case now, P is equal to omega 7.67 times by 4031.25 Newton meters. And that gives us an answer of that is equal to 30.9 kilowatts. That's the power produced by the load, not the motor. Remember, the system's not 100% efficient, so the motor needs to be bigger than that. But we come to that in part 5 of the question. Okay then, so part C asks us for the speed of the drum in RPM. Okay, so for the previous question, we had to find omega. We know that the speed of the drum is equal to 7.67 radians per second. Now, to get that to RPM, we know that 7.67 radians, we need to do 7.67 divided by 2 pi, that will give us our number of revolutions, and we want it in per minute, that will be revolutions per second, however we want per minute, so we need to times by 60. That will give us 73.2 RPM. Okay. Then we wanted the power produced by the motor. Okay, so we know that the power produced by the load was equal to 30.9 kilowatts. We were told at the start that the system is only 40% efficient. That motor has to work a lot harder to get out an output of 30.9 kilowatts. So we know that efficiency is equal to power out over power in. We're trying to find our power in this instance. This is what we want to find, our power in. We've got our power out, that's the power produced by the load. So power in is equal to power out over the efficiency. In this case is 30.9 over 0.4. Remember, that will give us an answer in kilowatts we put 30.9 in as kilowatts. So that's 30.9, so that is 77.25 kilowatts. In the last question, the speed of the motor in RPM. Okay, from our gears tutorial, we know that the speed of the motor over the speed of the drum is equal to the number of teeth on the drum over the number of the teeth on the motor. So we can say we know the speed of the drum, we know the teeth on both, so we can find the speed of the motor. So the speed of the motor is equal to ND TD over the teeth on the motor. We're going to use our value of RPM here to make it easier. We could use omega, but we'd have to convert back. So 73.2 times by the number of teeth on the drum is 125, and the number of teeth on the motor is 25. 366 RPM. Okay, so that completes our tutorial. I hope you found it helpful. Check out my other videos for more tutorials on these types of questions.